Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to take up the next and the last ionization technique, that is electrospray ionization. But before that, I would like to request you all to just go through the previous 3 videos that I've uploaded in the mass spectrometry series that include the rest of the 3 ionization techniques and the introductory portion of your mass spectrometry. So I request you to first go check that wisely and then switch to this particular video. Okay, so yeah, and without wasting any more time, let's proceed further. Alright, before talking about the last ionization technique, I would like to add on one more thing in your desorption ionization technique that I have not mentioned. I have just discussed about the matrix compound to be used in your MALDI technique, but I have not mentioned about the matrix compound that should be used in your SIMS and FAB in the previous video. So talking about the same, see, common matrix compound for both your SIMS and FAB, it could be, write down, you should just make a notes alongside with this video. That would be glycerol and thioglycerol, and comes 3-nitrobenzyl alcohol, 3-nitrobenzyl alcohol. Then comes di and triethanol amine, di and triethanol amine, and I should repeat, you should be making the structure of all these matrix compound that I mentioned over here while you are writing your subjective paper. So it will give you most particular, the presentation would be good. So which is why I request you to just make structure as well while you are attempting your subjective paper, correct? So yeah, that's all about it that I wanted to add in this particular technique. Without wasting any more time, let's just talk about your another ionization method, that is electrospray ionization method. See, this is the structure of your electrospray ionization technique. See, this technique, that is your electrospray ionization technique, it is even more useful technique for studying high molecular weight biomolecules or some other labile and non-volatile compounds. Okay, so talking about the non-volatile compound, I have already mentioned that you use desorption ionization technique also for your non-volatile compounds only. Okay, so remember that, keep this thing in your mind. Okay, and what is happening in this particular technique? A solution containing the sample will be sprayed out of the fine end of your capillary tube. See, this is the capillary tube and this is the tip of the capillary tube from where you will be spraying out the sample molecule into the heated chamber that is nearly atmospheric pressure. Okay, you are going to just spray out the sample. आप spray out करोगे अपने sample को through this capillary tip into the heated chamber which is nearly atmospheric pressure. Okay, done. That is first step. Now what is happening? The capillary through which the sample solution passes, it has a high voltage potential across its surface. This particular capillary is having high potential across its surface. You can see. Okay, high voltage is over here, that is 2 to 5 kilo electron volt. Getting that? And now what is happening? Small charged droplets are expelled into the ionization chamber. That you can see. These are the small charged droplets that are expelled into the ionization chamber. Okay, just let me go back to the previous slide. Okay. Yeah. So what is happening? Your capillary through which the sample solution passes has a high voltage across its surface and via which your small charged droplets are expelled into the ionization chamber. Now what is happening? These charged droplets, they are subjected to a counter flow of drying gas. Over here, they are now subjected to the counter flow of drying gas, and my dear, the drying gas that has been used over here is nitrogen. Okay, they are going to get subjected to the counter flow of the drying gas, that is nitrogen, which is doing the evaporation of the solvent molecule. Okay, what is doing? It will evaporate the sample molecule, and from where it is evaporating the sample molecule, it is going to evaporate the sample molecule from these charged droplets. Okay, so this is your sample ions over here. Understanding what is happening, the charged droplet which are subjected to the counter flow of your drying gas, जो कौन सी थी आपकी नाइट्रोजन, क्या करेगी, evaporate करेगी solvent molecules को into the solvent molecules को evaporate करेगी from the droplets. Understanding, your solvent molecules will get evaporated from the droplets. Thus, चार्ज डेंसिटी जो है आपकी हर ड्रॉपलेट की इंक्रीज करती जाएगी until the electrostatic repulsion exceeds your surface tension. मैंने क्या कहा, this line is quite important. जो आपकी हर ड्रॉपलेट की चार्ज डेंसिटी है वो इंक्रीज करती जाएगी जब तक जो आपके इलेक्ट्रोस्टैटिक रिपल्सिव फोर्सेस हैं वो एक्सीड कर रही हैं सरफेस टेंशन को. किसकी सरफेस टेंशन को, ड्रॉपलेट की सरफेस टेंशन को. आई रिपीट, if your electrostatic, you can write it over here, if your electrostatic repulsive forces is increasing as compared to the surface tension of your droplet, what is happening, your charge density of each droplet increases. Okay, and this will result into the breakage of your droplet into smaller droplets. The bigger droplet will get broken down into smaller droplet, and this particular limit where the breaking is occurring, that leads to the limit that is known as Rayleigh limit. तो क्वेश्चन पूछा जा सकता है आपसे that what is Rayleigh limit for 1 marks in your subjective paper. So you should be mentioning that the point where your electrostatic repulsive forces exceeds the surface tension of the droplet, and which leads to the increase in the charge density of each droplet, leading to the point where the bigger droplet breaks into the smaller droplet. This particular point is your Rayleigh limit or Rayleigh point. Understand? So ये प्रोसेस आपका कंटिन्यू रहेगा जब तक आपके पास एक सॉल्वेंट फ्री सैंपल आइंस ना रह जाए आपकी गैस फेज में. Understanding, this process will continue till the solvent free sample ions are left in the gas phase. So that is this electrospray ionization technique. Okay, understanding. And there is another method also, that is thermospray ionization, which is regarded as the cousin of your electrospray ionization technique. Okay, and what happens over there, it occurs by a similar mechanism, but it relies on the heated capillary method. Okay, this thermospray ionization is relying on the heated capillary method. Understanding what is occurring, it is using heated capillary rather than the one with electrostatic potential to form charged droplet. Over here what is occurring, your electrostatic potential is used for the formation of charged droplet, and over there what is happening, where over your thermospray ionization, what is happening, heated capillary is used. Understanding the difference between the two? So that is the thing what is happening over here. See to the next slide. So I have explained the diagram, and this is all the thing that I have mentioned. And even more useful technique for studying high molecular weight is your electrospray ionization technique. And what is happening, solution containing sample molecule is sprayed out at the end of this capillary. I have already mentioned all these things in the previous slide. And the capillary through which the sample solution passes a very high voltage chamber across its surface, and small charge droplets are expelled into the ionization chamber. अब क्या होगा, ये charge droplets को आप subject करेंगे in the direction of your drying gas, जो specifically है आपकी यहाँ पे नाइट्रोजन. क्या करेगी, वो evaporate करेगी आपके solvent molecules को from the droplets. Then charge density increase कर जाएगी आपके droplets की जब तक electrostatic repulsive force exceed करता रहेगा charge droplet की surface tension को, that is a Rayleigh limit, जहाँ पे आपका bigger droplet will get broken down into smaller droplet. Okay, so ये process आपके पास continuation में रहेगा जब तक आपके पास solvent free ions ना रह जाए आपके gas phase में. मैं आपको ये सभी बातें already ही बता चुकी हूँ. So proceeding further, okay, this we have already discussed. So yeah, that's all about your electrospray ionization technique. So yeah, in the next video we'll be discussing about the mass analyzer methods in detail. So yeah, I'll be stopping my video over here only. And if you have any sort of queries related to ionization method, you can mention in the comment section. And do watch the previous links that I mentioned in the description box also. So yeah, that's all about it. And for any of the latest detail, please kindly subscribe to my channel, press the bell icon. Thank you for watching. Do like, comment and share the link. Thank you.